All right, so we're back talking about section 3.5, the rational functions. They're a very interesting group of functions. They're our fraction functions. They make all kinds of interesting curves. We have these guidelines called asymptotes that we have to determine where they're located. So follow along with me, 3.5 rational functions. So I'm to the sheet where we've got a list of all the rules. I want to read through those with you to remind you all the rules we need to be aware of. With these, there's lots of little rules. The first rule, we always try to find the vertical asymptotes, and that is found by setting the denominator equal to 0. Simple one rule for that. It's just what makes it undefined. And these are brick walls. These are where the graph cannot be, can never cross, can never touch those values. So where the denominator equals 0 makes vertical breaks. The non-vertical breaks are found by comparing the degree. So the second rule says the x-axis will be a horizontal asymptote. That's the line y equals 0 if the numerator is less than the denominator. We've seen that on a lot. I feel like that's the most common one, where the numerator has a lower degree than the denominator. The horizontal breaks at 0. Y equals x over x squared. Y equals 0. Y equals x to the second over x to the third. If this top has a lower degree than the bottom, the horizontal breaks at y equals 0, which is the x-axis. We're going to see that actually on this one. If the degree is the same, the next rule, number 3, if they have the same degree, like y equals 3x over 9x, same degree x and x, you divide the leading coefficient, 3/9, which we would reduce. If y equals 2x over 5x, y equals 2/5. And then the next rule, if the numerator has a higher degree, like y equals x squared over x, then you do a synthetic division to find this slanted asymptote. Okay, we saw many examples of that in the last video, and we'll see some more here. Number 5, there can only be one horizontal asymptote or one oblique, but never both. They're mutually exclusive. They're found by comparing the degree. So you'll fall in one of those categories, but not 2. So it's just one of those, if any. Horizontal and oblique asymptotes can be crossed, but one time only. If they cross, they can't cross back over. Number 7. An asymptote's not part of the graph. It's the anti-graph. It's where the graph doesn't exist. The graph follows like this imaginary guideline to infinity, getting closer to it, but it's not part of the solution set. They're guidelines. Number 8, the vertical asymptote will be a brick wall. The graph just gets to that undefined point and it cannot cross it. It's confused, I always say. It's like, what is this? It's not even defined in math. So they're absolutely non-crossable, non-included. So as soon as you find any of the vertical breaks, you can go ahead and write your domain of the function, because it's already set in stone at that point. Number 9, you can have multiple vertical asymptotes depending on the degree of the denominator. If it's a quadratic in the denominator, you'll have 2 vertical breaks. If it would be to the 3rd degree, which we haven't really done one of those, but theoretically it could be any degree and have that number of vertical breaks. None to be crossed. Number 10, it doesn't happen very often, but if your fraction reduces, you should reduce first. Always reduce and leave a hole in the graph where it's undefined. Number 11, the vertical asymptotes determine where the domain is. You'll use parenthesis and union symbols when writing that. And then here are the 6 steps to graphing any rational function. If you're going to do it by hand, I encourage you to do that. Understand that as well as use your technology. Step number 1, find the vertical asymptotes. Step number 2, find the non-vertical asymptotes. Step number 3, find the x-intercepts, which is found by letting y equal 0. Step number 4, find the y-intercept. Those are things we kind of just generally should do in graphing. Step number 5 is our special step in this section, because sometimes you can cross this non-vertical. If you do, it's one time. So see if your graph crosses the non-vertical asymptote by plugging in whatever that equation is for y. And then number 6, then you have to just generally plot some points to see what works. All right, so here's an example. following along. Some examples. I'd like you to pause the video, check this out. What I'd like to remind you about on this one is we can use our old shifting rules. These rules that I just went over, all these rules apply to problems like number 14, 15, and 16. Let's see. Like this number 14, it's one fraction. It's one consolidated fraction. So all the rules apply to that. If it's in this form, where we've got some embedded graph and two separate parts to it, it's not consolidated, I would say. It's not just one fraction. The rules are harder to follow. So the rules are meant to be followed with one fraction, when you got y equals one consolidated rational function. These are meant to be graphed with the shifting rules. So just to remind you, we can use our shifting rules here. This is a horizontal shift because it's grouped with x. And those are always opposite, so we would shift it back 3 places. So our vertical break in the graph is moved back 3 places. You know, the embedded graph, y equals 1 over x, would have been here and here, the basic form of that. So it's been moved back 3 places, and this is the vertical shift. These are our old shifting rules. It's been moved up 5 places. I should have drawn that down here a little further. So it's the same old graph. You know, normally 1 over x looks like that, but again, move back 3 and up 5. So same graph, but just shifted, like so. Okay, number 13, try that one as well. Number 13, we're shifting the volcano graph, the basic shape. Let's see, it's got 2 over. So the embedded graph is the 1 over x squared graph. We talked about that earlier in this section. It has the 2 curves up there. And so we're going to shift that. This is a horizontal shift back 3 places. So there's the new guideline. And then that's a vertical shift down 1 place. So this graph gets moved back and down. So it's here and here now. Can you see that? So again, back 3. It's the new vertical asymptote. And then down 1, the new horizontal asymptote. And the 2 curves are in the top like that. Sort of like a volcano. Okay, one more. Next one. Try this one. Again, I hope you're doing these, taking your time, pausing the video to practice these. So y equals. Okay, let's go through all of our steps. Now, these are the ones where we got one consolidated fraction, and we can go through all the 6-step process. So let's do that. Step number 1, we're the vertical asymptotes. Luckily, it's in factored form, so I'll set each factor equal to 0. To see what makes the denominator equal 0, whether this part is 0 or that part's 0. When we multiply them together, we would get a 0 in the denominator. So we get 2 solutions of 1/2 and -3. Let's go ahead and start our graph here. So that will determine the domain of the function is definitely skipping over those 2 values. That's where it's undefined, at 1/2 and at -3. And so we've got one of those graphs with 3 sections, section 1, 2, and 3. And the domain would be stuff is going to be in here, and stuff over there. Vertical breaks. The non-vertical breaks are found by comparing the degree. So we got to figure out the degree. The degree of the numerator is 1 because we have an x and its exponent is 1. That's the degree. If this were FOILed out, we would have 2x squared and then some other stuff. But the degree is 2. So that's rules that says if the numerator has a lower degree than the denominator, then the horizontal asymptote is at the x-axis at 0. So the guideline is right there on the axis. So we've got our guidelines. Step 3, then find the x-intercepts. Step 4, find the y-intercepts. So let's remind you how we found intercepts. Intercepts are found by letting x equals 0 and then y equals 0, or vice versa. So the x-intercepts when y equals 0, this is y. So 0 equals this big O function. Now what I recommend, because it's a fraction, we can make this look like a fraction by putting it over 1. And then with fraction, if you have a fraction equals a fraction, you can cross multiply. So that's a quick way to solve this type of equation. It zeroes out the denominator. 0 times that is 0. And then 1 times that is just the that. And that actually is solvable. We will get a solution at -1. So it has an x-intercept. We can go ahead and dot that in at -1. Now what you might notice about that, that's the horizontal asymptote. So I've answered another question I'm going to want to know is, do we cross the non-vertical asymptote? And we sure do at the point -1. Now what is the y-intercept? The y-intercept's when x equals 0. So we can go back through this whole process. This time we'll plug in the x's as 0. So y equals, making x 0, all the x's 0. And then doing a little bit of arithmetic there. The top is 1. That's 2 times 0 minus 1. 0 plus 3 is 3. We can do that, right? That's -1/3. So it crosses the y-axis at -1/3, about right there. I'm starting to see some curve appear. You know, the graph either is stuck to go this way, or to be a U this way, or a U that way. Those are the possibilities. And then probably some sort of curve either in the top or the bottom, but it's stuck everywhere else. I have my guidelines. I found the only one place it can cross. Everything else now is solid. It can't cross anymore. Step 5 is, does it cross? We've actually answered that. Does it cross the non-vertical asymptote? You know, you can cross that once. And we have determined that it does. But the way you do that, if we hadn't already found that out this time, is you take the answer you found in step 2, the non-vertical asymptote, which was y equals 0, and plug that in for the y value and see if you're able to solve it and get an x value. And we did that, and we found it to be that point at -1. So we did that. And then 6, we just have to plot some points. We really don't have a lot of points on there yet, do we? So we would plot away. But I know you all use the graphing calculator, and I encourage it. So let's go ahead and type that in and just see what's going on there. The numerator, x plus 1. I encourage you to do this as well. Divided by the denominator. Notice I'm using 2 parentheses here, a parenthesis around all the denominator, and then the parentheses around that. Then I need a parenthesis to say all of that's in the denominator. Oh, 2 x's there. X plus 3, and close. I forgot a parenthesis around that. Daggone it. Cleared the whole thing. Oh, daggone it. Sorry. Patience is a virtue, right? I'm sorry to do that to you. Sometimes you hit the delete. I get this question a lot. I'm sure you've done that too. If you hit clear, it erases the whole thing. There is a delete button that will just erase the last thing you wrote in. And that's what I meant to hit. But also, I'll let you know that in case that comes up for you. Divided by denominator has 2 parentheses. 2x minus 1 is in one of them. And then in the other parenthesis, it is the x plus 3. I think I got that in there right this time. I hope I do. Graph. Okay, here we go. So here's the 3 sections on the graph. You notice the middle did do that zigzag. And then so you've got the curve that's stuck in the guidelines, these 2 curves that we see a lot, and then the middle does this zigzag. So then that helps us finalize our graph. This section looked like that. The middle section zigzagged. And then the last section was this section up here. And that's what you do for all of them. Basically, it's that process. All right, I think we'll need to stop there. I really wanted to get to 16 so we can see a slanted asymptote. And then you always have songs whenever I have the songs that match up with these, or a poem if you just want to read this. Barbara Akers, she wrote a book a long time ago. I was so impressed. She was very theatrical, and she had written songs that go with our algebra lessons. So I tack those onto your notes if you've noticed those. I think it's pretty cool. All right, if you have any questions, please let me know.